Okay, great. So myself, Amit Kumar Chaudhary, the head of technology and training division of Pragyatmika, welcome you all in this happening webinar on safety and security on lithium-ion battery pack design. There are the multiple of the aspects of a battery pack design are, whether it is the performance issue or it is the durability that you, whether that is the durability issue that you uh, expect from your battery pack. And the most and the foremost requirement is that the battery pack should remain safe and the secure. So the battery packs are now coming on the network. There are the lots of connectivity that you are adding in your battery pack. So it is becomes more important that the battery pack should remain secure from the network attacks also. There are lots of IoT related attacks that you must have heard of. So that should remain safe from the attacks also. So today's session is about that. What are the different of the vulnerabilities that your battery facing? Whether it is in the design phase or it is in the manufacturing phase, or maybe it is in your ideation phase also. What are the ways through which we can make our battery pack safe? What are the things that we should implement? What are the technologies that we should implement in our battery pack? And how we can make our battery pack secure also against of the different types of the attacks. What should be the features that my battery pack should be having? Right now, we are not thinking about it, but this is the most requirement now, because as more and more connectivity that you are adding into it, it is becoming more open and vulnerable. So these all the things that we are going to talk into the session. But before we move ahead into the session, I would like to know that how many of you are joining first time any of the program of Pragyatmika? How many of you are not aware about Pragyatmika, or how many of you are first time joining the program, any of us?
Myself, Tapos Majumdar, first time I think.
Okay.
And I know Pragyatmika very well.
Okay, thank you, sir, to recognizing us. And others have already have joined. Okay, that's good to know. So welcome, Mr. Majumdar, for the first time as you are joining. So hope this session will remain useful for you. And the same will be for, okay, Mr. Pradeep, you're also joining first time any of our program. So I just let you know that who we are, what we are doing, and how you can get benefited through our services. In just a quick one slide, I'm just discussing you, so that for new and if you have forgotten, if you have already been joining, and if you have forgotten that what we are doing, so you can have an idea. So our headquarter is in NCR, Delhi NCR. We are Delhi NCR based organization. We have the services from the Bangalore and Pune locations also. And we are into the technology, training and consultancy, the three things. Technology we provide to the manufacturers, to the battery pack manufacturers, to the EV manufacturers, thereafter in the EV domain specifically. Thereafter the microelectronics domain, we are having the expertise into the embedded systems. Thereafter the IoT domains, industrial IoT domain, industry 4.0 implementations, automotive electronics, industrial electronics. In all these domains, we are providing the research and design services like any of a company that requires the product development or a technology development. So we create the IPs for them, we create the product for them, which they can manufacture later on. That's what is our technology wing does. The training wing is specifically for the professionals training. Majorly, we do the trainings for the manufacturers, thereafter their employees, and the professionals and entrepreneurs who want to enter into the domain, a battery or electric vehicle, or say microelectronics, IoT, and all these things. We are a training partner with Microchip. Thereafter, we are empaneled with, I am personally empaneled with MSME also, to create the ecosystem for the skilling and the entrepreneurship. Thereafter, we are having the services for the institutions also. So academia is also getting benefited with us. We create the customized programs for them, so that the gap between the academia and the industry could be filled, and the kind of internship and all these opportunities that we provide. Earlier, it was the centralized internship opportunities, but after the COVID scenario, we have started offering the decentralized from where you can work from your city also and can be on our projects. For the internships and all, we are under the certification process of UK. So this is a government of UK body which gives the project certification. So that's what also we are looking at. And maybe from the next quarter, once you join internship with us, so you can have the NOC and certification also that is worldwide acclaimed. For the IoT domain, for the embedded systems domain, for the microcontrollers and microelectronics domains, we have the micro certifications that is also worldwide acclaimed. We have services all across the globe. We are serving in the European and American zones, mostly also for the training and the technology domain for India and the African domains. These are the countries we are serving in. We have the in-house R&D facility. We support to the startups. We support to the MSMEs for bringing up their products and the prototypes and make them live into the domain. So these are the brief of our services are. Now you must be wondering that who am I? Who is letting you know. So as I have told you, my name is Amit Kumar Chaudhary and I head the technology and training division of Pragyatmika. So I have been in the technology domain for the last 14 of years. In my earlier days, I have worked with IT Delhi, thereafter DRDO, IBM in the research and design positions, different projects I have handled, some of the critical projects I have been worked with. Thereafter, I have completely moved towards the entrepreneurships and we have established 3 companies into the different of the domains related to this. So Pragyatmika, A+ Technologies and all these are the companies which we have established for the serving in the different of the domains of the technology. So Pragyatmika is where I am looking after the technology and training division completely. And my expertise is, it started into the microelectronics. Thereafter, for the last 8 years, I have been into the EV domain. I have served to many of the, the company has served to many of the large fleet operators. Thereafter, the EVs for their products on board. So this is whether it is the EV systems, thereafter the battery BMS systems, all these worked on. So what we are going to talk today, it is about the behavior of the lithium-ion cells first. Thereafter, what are the performance that you expect from your lithium-ion cells and the batteries? What are the measures of a safety that you should keep in your pack? How we can implement the measures of a safety into the pack? What are the security vulnerabilities and how we can make our battery pack secure? These all things are the part of your designing process, but that is not enough. Once you have, even if you have done a very good design of the battery pack, like many of the time it happens with many of the people, might be you are into the battery consultancy domain or into the design consultancy domain. Many of the time it happens that you have given a foolproof, very good product, very good design to your manufacturer, but the good of manufacturing practices has not been taken care of and the product fails straight away into the market. So that's what is also very important, that you have to give into the blood of your manufacturer, of your client, that what is the exact manufacturing practices that it should keep, what are the machineries, what are the things that it should keep, so that a foolproof product should come into the market and that should be reliable. It should be performing, it should be safe, it should be reliable, all the things that should be there. So few of things that we will be discussing about the design to manufacturing practices also into this. What are the case studies? That's what I will be discussing some of them today. And let's start with the session. Now, I'm keeping my video off so that you don't have distraction. And start the session. Okay, so before I'm going into the technical details of all the things, let me have some discussion on the pain point what the manufacturers have. Many of you might have joined here today are the battery manufacturers. I've seen the list. There are many of the battery manufacturers have registered for the program. So whenever you are going to get a battery pack, So what are the expectations of your customer are? So your customers are the EV manufacturers or maybe your dealers. So what are the expectations they have? I have point, and then it becomes a very problematic or very confusing job for you, that whether you're making a performing battery or you going to make battery. I request everyone to keep your mics shut off so that it should not be a disturbance for anyone. Otherwise, shut off from this side so you won't be open to further. So please do this thing. Keep so that you can talk me whenever it is necessary. Okay, so these are the pain points. So whenever the battery pack that you are designing, so the first thing that comes from your customer end is that how much range that battery pack is going to give you. Remember that this is what I have brought out specifically towards the perspective of electric vehicles, but this is not limited to the electric vehicles. This is similar in the other domains. Lithium ion is not limited to the electric vehicles. It is there into the solar domain. It is there into the energy storage domain. And now the UAV domain is coming up. So in all of the domain, the similar offer demands that those will be there. So be ready for the other domain professionals also, but this is what the most of the time the demand comes from the EV manufacturer side, that the battery pack should be giving a very good range. It is not like 80 or 90 kilometers. Even if it is a very small battery pack, it should be giving me at least of a 180 kilometer or 200 kilometer. But even that this is the demand of the customer also. Even that EV does not go more than 20 to 30 kilometers in a day, but still the customer wants that the range should be 200 kilometers. So that's what is a very big pain point, because that drops the all of a kind of innovations that in the battery pack that you want to do, but you are not being able to do because you have to give the performance of that 100 or 200 kilometers, and you don't have the space and the flexibilities. So this is a big problem. The second of a problem is that the charging. Everyone knows clearly that there are the certain of a charging restrictions are there into the lithium-ion domain. If you will not follow those charging restrictions, the things what it is happening, you must have been seen those circulating videos. I'm not saying that it is only due to the charging, but it is a more of a chances that if you are not following those charging profiles, the performance of your battery pack, the safety of your battery pack, and the durability of your battery pack all is compromised. So whether you are giving the fast charging in your battery pack at a cost of your performance, or at a cost of your safety, or at a cost of your durability. So 1 minute swap is possible, but there is a demand that it should be charged within 1 minute, 30 minutes, 40 minutes. That's what the demand remains. So that's what the good charging rate, that is the demand. The more of a connectivity everyone is demanding, so that the more of a data from the battery pack he can get. The cycle life should be unlimited. He has not to replace the battery pack any of a time. That's what is remains. And having all these facilities, the battery pack should the battery pack should remain very less weight. It should have very less into the size. So this is also a demand remains. So just think of that. You have to give a very big battery pack, a battery pack which is giving a 200 kilometers of a range, that is having the all a kind of a communication. So you must have to add the multiple of the transceivers. You must have to add the multiple of the safety mechanisms for the communication of all those transceivers. The charging you have to add of a like a fast charging you are going to add. So the method of a thermal management that you have to add, and that is going to add the cost and the size of the battery pack. But the demand is that I have a very limited amount of a space in my vehicle. Can you please make the battery pack into this limited space? That is also a very big pain point for the manufacturers. And after all, I need each and everything, but price should be very low. It should not go beyond of XXX rupees. You should not make any profit on them. It is like a charity that you are doing in your business. So that's what the requirement remains. How many of you agree? How many of battery manufacturers who are connected today agree with my voice? No one agrees? Or no battery manufacturer has joined yet? Let's keep this session interactive. Already it is a afternoon time, very boring one. Okay, maybe you have not encountered such things. Let's move ahead. So I wish you come into the manufacturing domain fast and see that what is happening over here. Great. So the choice is now the choice comes on you now. Whether you are giving all such kind of things, make your battery pack a very live one, giving all the kind of communications and all, or you are sticking to your boring battery pack, which has just cells and a small BMS, which is taking care of the management of your pack. Whether it is a choice on yours also, that whether you want to keep it performing and you want to add the elements of a safety in your pack based on the different of a features that you are adding. Based on the different of the features that you are adding, so more and more vulnerabilities is facing. So whether do you have the scope to add the safety measures in your pack or not? So it becomes a very big dilemma for you. So this is not the pain point of the battery manufacturers. The pain point of the EV manufacturers are also similar of. You are only into the battery pack, but the EV manufacturer has to deal with lots of things. It's not only the battery pack, he has to deal with the traction inverters, where thereafter the motors, the complex motoring system he has to deal with. There are the multiple of the MCUs are there into the system and the VCUs. Thereafter the vehicle communication units, thereafter the control systems, the communication systems. So lots of type of a different complex system he has to deal with in the mechanical and the electrical and the electronics. Apart from this, he has to deal with the multiple of the challenges, which is a very practical one. Right now the EV ecosystem is coming up, so we don't have the enough manpower which is skilled as per the demands of the EV manufacturer. There are the people, but how it should be for the EV manufacturing, it is a dearth of the people. The attrition rate is high. It is a very big problem that the production does not remain sure. So how many number of pieces in this month will go into the market, how many number of pieces would be selling. So it remains always an uncertainty. So as per that, you can't establish a good production line. You can't do a good of a prediction of your production. So that's what also remain a challenge. We are heavily import dependent market, whether it is our cells or the battery components, thereafter your EV components, many of the things are import dependent. So the inadequate supply chain is there. And the people who are involved into this, whether it is the owner or the entrepreneur or the top level employees, so also they are not very much experienced into the EV manufacturing. It is new. It is not their problem because it is a new thing. EV is a new thing. So people will get used to the thing. So right now there are the not of a good manufacturing practices, documentations, like it is there into the IC engine vehicles, or the people who are already into the IC engine vehicles, they are shifting towards the EV. So there are the shift issues are coming up, such kind of issues are there. And because the things are import dependent, so we don't have the enough flexibility for the traceability and the defect analysis also. There are the multiple of recall cases you must have heard of, like a Bolt EV has to, the General Motors has to recall the batteries of the Bolt EV. Hyundai has to recall the batteries of a Kona. So some similar of scenarios you must have heard of. Now, if we don't have the traceability of the components, and if we are not maintaining such traceability of the components into the log, so how would we know that which one cell which has gone to which battery pack, and if I'm recalling, so it is a complete mess that we will be creating. So these are the standards that is already made into the IC engine domain, but these things are coming up into the EV. So these are the problems everyone is facing. And even after facing all of these things, if we come up with a EV, then there are the issues of coming like a fire, or maybe the performance. So market is not accepting them. So this is what we are going to discuss today, some part of it. I'm not going to discuss today that why EV is catching fire. There are the lots of issues are there. I'm going to discuss you what are the safety that we should keep in our design and the manufacturing phase, so that such kind of a scenarios should not occur, because no one can say, even the company whose vehicle is burning can't say at a moment that why my EV has got burnt. It requires a long of a research. It requires a long of a defect analysis process. So no one can say this thing. Even like a General Motor Bolt EV, I've written it over here. Bolt EV has to recall 3 times within a 9 months of a period. It's a battery pack of its electric vehicles. The General Motor has to recall. So you can think of that General Motor is a well-established, Bolt EV is a well-established EV, and there were the problems into the battery pack, and it has to recall 3 times within a period of 9 months. And you were amazed that there was no issue of a design, there was no issue of a manufacturing of the battery pack. The General Motors put out a paper after 1 year. So last year he has rolled out this paper that why my vehicle batteries were burning out. So even into the parking lots it was burning out, because the which was used for the battery packs were at fault. So it was LG Chem cells, the LG Chem pouch cells the Bolt EV is using. And there were the issues into the manufacturing practices that there are the wires that is connecting from the electrodes to the terminals of the cell, and there was issue into the connection of those wires. So after the vibration or the vehicle was running on the road, so those wires started tearing off, and that was creating a short circuiting between the electrodes of the cell. That was a big one issue with the LG Chem cells. It is there into the manufacturing process fault. The second of a issue that was there, the separators between the electrodes of the cell was having a little of a rolling on the corners. So like just a moment, I depict you. So like if this is a one electrode, on behind of this there is another electrode, and in between there is a separator. Now there was a certain of a rolling on the corners of the separator was there in the few of the cells, and this this absence of the separator on those corners was creating a issue of short circuiting between these two electrodes. So you can think of that it was actually a cell level issue which was not recognized neither by the LG Chem nor by the General Motors while making the battery pack. They have deployed the battery packs into the domain, into the market, and it created a big such kind of a big issue. So that's why the cell level spectroscopy is also becoming mandatory now into the multiple of the companies, so that from the very beginning of the picking of the cells, so whether the any kind of internal cell issue is there or not, that's what one can see. I'm getting a multiple messages for a person. Which side video you are not? I'm not playing any video as of now. Is this problem everyone? I'm not playing any video. Is my screen completely visible to everyone? Please respond through chat window. Yeah, okay. Okay, so it is, so that's what the thing that I wanted to indicate that it is not the battery pack issue, it is the cell level issues that could also be. So we should not be very conclusive at just one point that, yeah, this is the region. We have to, whenever any such kind of a issue occurs, we have to see that what the company says, what are the regions behind of it, what kind of researches have been done, what kind of a defect analysis has been done, and then a paper rolls out. So these are the processes that one has to follow. Okay, so there could be the assembly issues if you are not following the complete of a rules of a mechanical design or electrical design or a thermal design. So such kind of a problems that can happen, the electronics failure can happen, your cellular failure can happen, as I have just talked now, or maybe complete of your design flow. It is battery pack is not just about the making the cells into the series and parallel and doing the a nickel strip welding over it and the battery pack is done. That's not. So it is a design flaw is there. So if the fire is due to the battery pack, such kind of a issue is there from the inside of the pack. Thereafter, there are the user behaviors issues like of a fast charging. Even if the battery pack is not supporting the fast charging, we are doing a fast charging of it. So it is at the cost of a safety that we are doing, because it will be definitely increasing the temperature. If there is a no active thermal cooling system is there inside our pack, and then we are doing, so it is going under our over or low temperature conditions, that can also lead to the failure of our pack. The electrical hazard conditions like connectors are not good. If the connectors are not good, or it is the maybe your short circuiting is between of your strips or the bus bars. So such kind of a problems. Thereafter, the security. If your vehicle or if your battery pack is on a network, so that could be easily, if there is a no security certificates are attached with it, if it is connected on a cloud and no security certificates are attached, so it can be easily hacked, and your vehicle can be turned into a live bomb. So you must have heard of the Jeep attack, where the through the infotainment system the vehicle was hacked and made a crash through it. So such kind of things are very common. It could be done very easily. There is a no very hi-fi kind of a knowledge is required for such things, and if you are not implementing, so it could be done. So these are the some of the regions into the EV. Few more I have brought out. It is the raw material is again a very big issue. Specifically in context of India or maybe African zones, people are, or maybe the Latin American zones, the people are doing. So they are not, the import is particular of countries like China, South Korea, Japan, North USA. So all these are the countries the cells are coming. So we are not getting the grade A cells. Even if you have purchased the grade A cell, but it has taken 3 or 4 months to come to your country. And during this, what was the transport conditions, under what of the temperature conditions it was brought, no one knows about it if it has not been maintained properly. So that thing will degrade your pack. The health of your pack, of your cell will be definitely drop. So mostly it is the B grade cells, those are available. Even the companies are not selling the A grade cells in Indian market. So that's what is a big issue remains. So how do we mitigate these issues? So there are the possibilities that these cells will get manufactured over here. So that's what would be the one solution. Even if you are getting like A grade, the down of a grade or a B grade cell, so you should have the enough process or mechanism to do the sorting of your cells properly, that the good of a pack that you can design from it. Thereafter, the design flaws, as I have talked about, we already are remain most of the time under pressure of the cost cutting of the packs. That's what also a big and issues. And we are just concerned about that getting the pack. We don't consider about the safety or the if the pack bursts or if the thermal runaway starts. So what will happen with my pack? So we can't make many of the time arrangement for them. So these things are issues that remains. The manufacturing process, as I have talked to you, the charging systems, even if your battery pack is not supporting to the fast charging or the public charging network, you enter into it, and that creates an issue for your pack many of the times. It mostly create your it mostly works, degrades your life cycle of your pack and the health of your pack. The powertrain which you are connected with your pack, that also remains some issues many of our times, as it starts drawing higher of a current, and your BMS that is connected with your battery pack is not an actual a BMS, but just a protection device. So there are the BMSs which is there, which is a rigid device which has a certain of a cutoff levels, like for the high cutoff level, the low cutoff level, the current cutoffs. So such kind of a rigidness into the BMS is there, and that BMS fails many of the times based on the current and the temperature conditions. And that time, if the powertrain starts drawing the higher of a current from the pack, so that will heat your pack at a moment. So such kind of problems are also the issues. Thereafter, the customer behavior is another thing. So when you are using the EV, you need to be aware about the EV. There are the question comes that can my vehicle run in 50 degrees centigrade? Can my battery pack stand good in a 50 degrees centigrade? Yes, your battery pack can stand good in your 50 degrees centigrade. You are comfortable in that 50 degrees centigrade. So the battery pack, the lithium-ion battery packs are as good as comfortable where the human is. So if you are comfortable in 50 degrees centigrade, definitely your battery pack will be. But if you are not comfortable, then your battery pack won't be. So just think about it and work based on this. There are the charging behavior problems remain many of our times with us. Thereafter, how to use the vehicle, like there are the ranges parameters are given, and just for my fantasy, we start driving unhealthy conditions for the battery and for the vehicle. So those are the common issues that has been found out. The standardizations. So many of the people think that there are no standards for the EV yet, and there are no good standards for the EV yet in context of India specifically. But that's not true. The standards are drawn, and there are the good standards drawn. The things are that many of new things are coming up into the EV domain. So the improvements keep going on, but the standards are there, and one has to adhere those standards. Mechanically, the battery pack can fail if you have not made a good arrangement of the vibrations arrangement for your battery pack. So definitely the battery pack can fail due to the mechanical regions network. So these are the different of the issues that the battery pack can have, and your vehicle can also have such kind of issues. So what is the solution? What kind of things that we should apply in my pack? At least of a few of our measures that we should have. We can't avoid such kind of things. This thing will remain because this is a consumer centric thing. It is not an industry centric thing. It is a consumer centric thing. And vehicle, well, once the vehicle will go in a hand of a consumers, so it will go to in the hand of any type of a consumer. You can't have a control on that consumer that you have to use my vehicle under these conditions, only then it will perform. You have to make your things so sturdy that under any circumstances, it should not fail. At least it should not create such a kind of a hazard which will take the life of that person, because it's very much related to the life of a person. He is either he is driving your vehicle on the road, maybe it is in his parking lot, maybe he is standing near his vehicle, and then your design is not so strict that it will take the life of him. So these things at least you have to ensure because of the usage of these things. So we will have a discussion in this respect only, that what should be the safety measures that our pack should be having, specifically at the battery pack related things that we are going to talk today. But before of that, once we go into the things, let's see that what is there inside of the lithium ion cells are. Many of you might have cut the cell and seen it, but just for the interest of the large interest, I'm showing it again. So this is the internal block. That's what you can see. So we have the electrodes. Those electrodes are the cathode and the anode. The cathode part is your lithium cobalt oxide. So, and the anode part as of now is majorly the graphite materials are there, if it is the NMC chemistry or what I'm talking about. Then in the cathode part, there are the current collectors are there. So cathode or anode, these all are the in the form of a slurry, and this slurry is pasted over the current collectors. So it is the aluminum current collector and the copper current collectors are there, on which that is there. And whenever the charging and discharging process is happening, so it is the lithium ion that is changing its polarity. So from the cathode side to anode side, and from the anode to cathode side, this lithium ion is moving. So that's what the best thing about the lithium ion is, because the ions are changing its positions from the cathode to anode and vice versa. So it is not getting decayed. Even if the battery pack health is gone, but still you can recover the lithium bit. So it is something like the inner. So as long as that energy is in your control, it is good for you. You can do n number of things with that energy. But if that energy goes out of your control, it can explode. So similar of a thing for the lithium ion is also, if you have created well enough environment for the working and for the behavioral practices of the lithium ion, it will keep giving you the energy. But if the temperature or any other conditions have gone beyond of the limitations and beyond of the requirement of that chemistry, so it will definitely explode. So this is the current structure is. Let's have a small look that how it is from the inside. So there's a video which is there for you, how it is there from inside. Sorry. So this is a cell can. It is a cylindrical cell. It has been cut. So it took almost of 30 minutes, and so on both of the sides we have this. So as I have talked to you that this is the electrodes are there. So you see here, the white is the separator material, that is of a polyvinyl material, and the separators. So as a form of a current collectors, the copper and the aluminum foils are there, on which this anode and cathode slurry is pasted over. So just. this slurry is there. Now, so in between this separator material is there. And then we have this cathode material, which is there, polyethylene. So separator is used for your isolation between the cathode and the anode. So this has what happened with the Bolt EV, that on the corners, this separator was teared down. So that made the short circuiting between the electrodes, the cathode and anode, and that's where the batteries were exploded. Okay, so this is how the cell is from the inside. So here it is, the lithium cobalt oxide is there used as a cathode material, and cobalt is a very unstable material. So that's where the one of the reason behind of the lithium ion being the lithium ion chemistry, the NMC chemistry specifically being very unstable on the higher temperature. So it is the cobalt is one of the reason behind of it. So there are the other chemistries also, which is a little more safe. So we will have a discussion. So that is the inside. But when we talk about the safeties and why the battery packs are failing, so there are the 2-3 things that we have to consider always, and that is in the design phase specifically. So the batteries should have the thermal design, the mechanical design, and the electrical design. These 3 things specifically. Under your thermal design, it comes about that at what temperature levels the battery packs are coming. So what is the exact of a thermal management method that you have to apply? What is the whether you have the provisions for the active cooling system or a passive cooling system? Normally for the 2-wheeler or 3-wheeler packs, we are very cost sensitive, and we can't apply the active cooling system into it. So even if the passive cooling system you are applying, so up to what temperature level your battery pack can go, and for that temperature level, whether you are allowing the fast charging or not, that's what also you need to model. So all these things are done on the modeling. There are the mathematical modelings first, the calculations part, and thereafter, if you have the access to the modeling software, so it is better to do the modeling of the complete of the pack. Then it is the mechanical things that we need to take care of. So what will happen if the vibration the pack is facing? What should be the gap between of the cells so that the vibration should not propagate, or the heat should not propagate between of the cells? And related to the electrical hazards, we always have to take care of that the bus bars or the nickel strips which you are using. So the internal resistance of those materials first, it should not be high, so that the more of a droppage and the heat should not occur during the transmission of the current from one cell to another and finally to the load. Thereafter, the wires or the connectors which you are using, the sensors which you are using for the temperature measurement, the length of them. Thereafter, the BMS which you are using with your battery pack. So the BMS has the wires going on for the sensing of the voltage to the cells. So the length of those wires also needs to be taken care of, and there are the proper of a calculations are there, which ensures that the similar of a balancing within the cell should happen. Like for one cell, if it is maybe one centimeter of a wire you have, and for the last cell module, if it is a 20 centimeter wire you have taken, so there is a difference of a 1 centimeter and 19 centimeter difference is there in your wire length, and there will be the difference into the resistance because the wire will have the resistance. So it is the more of a voltage drop that can happen, and the less balancing of the cell that may occur at the extreme parts. So these things are considered while doing the design of the pack. So this is what, even if you don't have the scope for addition of your thermal management methods or scope of the specific of a safety methods in your pack, but at least of these things you have to ensure so that even if you are boring, batteries will remain safe. Even if you are not applying any kind of IoT device for the measurement or a battery monitoring device in your battery pack, but if these things you are following, at least of a 60% or 70% of a safety you are achieving through your designs only. So these are the big hazards are there in the design. Most of the people are not following this. They are just going with the what is available into the market, and it creates a issue that way. Like the casing available into the market, what is the bus bar available into the market, they don't do the calculations for this, and this is one of the very big issue. Even if you have done a very good design of your pack, but still there are the abuses that will happen to your pack, and those abuses could be done at the manufacturing end or at the customer end, and that will lead to the loss of safety of your pack. So mechanically it could be abused, where it is the crushing or penetration of your cell will happen due to the crash of the vehicles. So maybe the placement of the battery pack is not in a good way, which so where the even if the accident occurs, so the battery pack can get crushed. So it is the deformations and to the separator tearing of the cell will happen. Electrically, like over a time period, there are the dendrites are grown into the lithium-ion cell, because the electrolytes are getting older and older, and those later on that dendrites start growing on into that, and that pierce the separator. So that dendrite growth or the piercing separator will come under the electrical abuse conditions. That will happen if the excess of a charging or overcharging or over discharging of your pack you are doing, like it is a 20% to 90% is the generic SOC measurement standard we need to follow. But if you are doing the charging up to 100%, or maybe you are discharging your pack below of a 20%, so your health of your pack will be lost fast, and these things will come faster. So that's the abuse that you are doing. And later on, it is the everything converts into the thermal impact. So whether you are doing the mechanical abuse or you are doing the electrical abuse, at the end of the day, it is the internal short circuiting happens between of your electrodes, because either your separator will get pierced off, or if the temperature rises, so your separator will get melted down, it will just evaporate, and your electrodes will come into the contact. So internal short circuiting happen at the end of the day by any of your abuses that leads to the thermal runaway. That's a kind of a chain reaction you can think of, that where like temperature rising, due to these problems, the temperature within the cell rises, and that rise into the temperature of the cell will further further lead to the excess bleeding of a current from the cells, and that excess bleeding of a current will further rise the temperature. So it is like a chain reaction, and finally the cell will burst out, where the electrode materials will come into the contact of a direct air oxygen, and the battery pack will come into the fire. So this is a complete of a process that happens when the a cell will get heated. So that's what is a thermal runaway complete process is. And in this process, the first of it, your separator will get vaporized. It will get teared off, and the short circuiting starts happening. So initially it is like a internal short circuiting is the common cause for that a thermal runaway happens. So if we have the mechanism that first we need to avoid this thermal runaway, like many of the people are using the BMS. BMS is just a protection device. It is not going to give you safety against of the many of the measures of your battery pack. It is giving you safety up to an extent for the known electrical regions, like it will not allow the battery pack to go overcharging or over discharging. These things it will not allow. But think of a scenario that by any of a means, if the separator tearing has happened, the temperature is rising, so it can just record if it is a good BMS, so it can just record the rate of change of a temperature, but it will not be able to do anything. So for such kind of a things, we should have the access of a safety measures apart from the BMS. If there is a mechanical failure in your pack has happened, if there is a crushing of your pack has happened, so maybe the BMS would stop functioning, because it may get crushed also. And that time, if the fire is there, so how will you douse it? So for that thing, there should be the separate of a mechanisms, and all these things come under the safety aspect of your battery pack is. So whenever this thing occurs, so it is a stage-wise process. So first of it, it is the battery abuses that you do. So that leads to the failure of your battery pack. The second of it, the material gets degraded. Your separator will start vaporizing. Thereafter, your electrodes will get into the short circuiting, and that short circuiting will lead to the further vaporization of the electrodes also. And finally, it is the thermal runaway process is the complete of a thermal runaway. And in all of this, the temperature starts increasing. It is not a linear increase, it is an exponential increase starts happening. Within 5 to 6 minutes, the temperature can go from the 40-45 degree to even a 150 degree centigrade or 175 degree centigrade. Within 11 minutes, everything vanishes off, practically tested. So this is the thing happens. So it is the cell crushing or overcharging, separator tearing or dendrite growths. All these things lead to the excess bleeding of a current, which further lead to your separator melting down. The temperature further increases and your cathode decomposes first. Thereafter, due to the cathode decomposition, the oxides are emitting out, and that comes into the direct contact of air oxygen, and the further the heat is there, that the fire is there, and that leads to the heat. So many of people who are involved into the fire dodging, the fire extinguishing, so they also see that it is not a very, like, even that, like, that fire is caught, like if a fire is caught in a battery pack, so if you use a water, so that also creates an issue. If you use a normal fire extinguishers, that also does not create an insulation between the air oxygen and the battery pack properly, because already there is an oxide inside. So the halon type of a fire extinguishers are generally preferred over here. If the water is used, like many of our vehicle fire cases, the water were used. So there was a huge number of tankers were used to douse the fire. It was not just some buckets of a water that will douse the fire, because the oxide is present over there. So that's what the loss of a safety will lead to the thermal runaway and to the fire and the heat. And this is not the problem with one of the chemistry, or like many of times in the market, you might be, many of the times you might be hearing of that it is the NMC chemistry that is at a risk, LFP is safe, but that's not true exactly. The problem is there with chemistry almost, and somewhat less or somewhat more. Everyone has a restrictions, everyone has temperature limitations, everyone is having the density restrictions, and based on which it is the behavior of those chemistries are. So like your NCA chemistry, that is the most volatile chemistry it is thought of. So it is the specific energy is quite higher, but it is the at the aspect of a safety, it is the least stable, because almost the temperature at a 150 degree centigrade, theoretically, the thermal runaway comes for these chemistries. The life is higher, the cost is low, the specific energy and the power density, that's quite higher, but on the part of a safety, it is a little lower. The NMC, which is a very common one used for the two-wheelers domain, specifically the UAV domains. Thereafter, your energy storage domains, also many of the people are using it. So there also it is the density is quite good for it, but on the aspect of a safety, it is little unstable. It is more than NCA, but it is more safer than NCA, but less than many other chemistries. Similar is a thing with their chemistry also. And LTO, which is a thought of a durable chemistry used for many of defense and space applications. It is more a good on a safety aspect, but you don't have the good of energy from it. So that's why you can't use it for your electric vehicle applications. Mostly you can't get the density and the voltage. LFP pack is having the less of a density, but on a part of a safety, it is thought to be good, because we have in approximately of a 10-degree advantage in the working conditions. Like if it is for the NMC, you are it is a 25 to 40 degree centigrade or a 45 degree centigrade. Some of the people are using it by access of a cooling mechanism, the performing battery packs. So LFP can go up to 50-55 centigrade by those means. So that's what a 10-degree advantage we have, and many of the people are advocating for the warmer temperature zones, this chemistry. But because density is lower and the voltage is lower. So for specifically for the two-wheeler applications and specifically for the scooter applications, this becomes a little uncomfortable because the size of this LFP chemistry cells are quite bigger, whether it is the cylindrical cells or it is the prismatic cells. So the size is bigger, and the higher bleeding of the higher self discharge is there in the LFP chemistry. So every chemistry is having some good points and some bad points. It is completely dependent upon your application. What is your requirement? You need to select the chemistry, the safety that you will have to ensure. Every chemistry is unstable, every chemistry is safe, and every chemistry is unstable. That's what the same thing is, that if you are not having a good of a design of your pack, the thermal design and the electrical design and the mechanical design, these three are the basic things. If you are not having that thing, so even the LFP pack can be a disaster for you. But if you are having a good design aspects, so you can go well with the NCA chemistry also. Like Tesla is using NCA chemistry and it is a good chemistry they are using. So this thing is, so we have not to be very judgmental about the chemistry. That's why I had a comparison over there. The thermal runaway, I'm again taking into the consideration. So thermal runaway mostly occurs into the battery pack when there is an internal heat becomes more. So the rate of whenever the battery pack or cell is getting used, so there is the heat is generated. When that rate of generation of heat exceeds beyond the rate of exertion of that heat, it explodes. So I have maybe just a chamber. You can that I have a chamber, and there is a vent in that chamber. So there are the heat that is getting expelled out through that vent from that chamber. But suddenly the rate of production of that heat within that chamber is so high that the rate at which it should exert out, the rate of production becomes higher than exertion. So it will definitely burst out. It will definitely break that seal which is there on the top of that chamber, and similar kind of a thing happens in the cell also. As I have shown you in that video, there are the two sides of the cell which we had cut, and that terminal on the cell that is used as the cap, so that the access of a gas which is getting emitted out during the reaction, whether the charging or discharging you are doing. So through that vent, the gas will get emitted out. But if that rate of production of the gas is higher than the rate of emission, definitely that cap will burst out, and that happens in the case of a lithium-ion thermal runaway process. So why it is happening? Because there are the organic salts are there in the form of the electrolyte, and whenever the reaction is happening, so that gases are emitting out. This is normally an exothermic reaction, but whenever it is not related to the temperature conditions, this thing can happen at the lower temperatures also, and this thermal runaway can happen at the higher ambient temperatures also. Like for an example, you are at your good temperature conditions for your cell is 25 to 40 degrees centigrade, and you are operating you are doing a fast charging of your battery pack maybe at a 5 degrees centigrade or maybe 10 degrees centigrade. So at that time, the internal resistance of your cell is quite higher, and the more of a blockage of a current that will happen. So that time, if you are doing the fast charging, so definitely you are going to rise the temperature of your cells. So it is not limited that only at the high ambient, if there is a heat and there is a summer, only then the cell can burst. Even it is the colder environment, even it is the winter time, and you are not following the proper of procedures, so your cell can burst. So it is the agnostic of the ambient temperatures. There is a more of an impact happens in case of higher ambient temperatures. The rate of goes higher, the rate of a production goes higher, rate of production of a gases goes higher, but I don't limit you to the higher ambient temperature zones or only. It can be at the lower temperature zones, and the more of a cell health loses at the lower temperature conditions also. Here is a few of the videos we had recorded earlier. So I just show you that how this thing happens. So normally we have a thinking that it is like a 50-60 degrees centigrade, or maybe 70 degrees centigrade, the ambient temperature is, so battery pack will burst out. But that is not exactly. If you are having the proper of a mechanism, so it can withstand to even a higher of a temperature. So here, see the video. Here it is a 200 degrees centigrade, as you can see. So this is a thermal chamber. And in this is NMC, single cell structure is, prismatic single cell structure this is. And you see there is a vent structure is there. So even if once the temperature has gone at a 200 degrees centigrade, there was the vent inside of the a cell. Through that vent, the gases are emitting out. And in us, lots of time we have been told that LFP chemistry does not catch fire, but just see over here, this is a LFP, this is a LFP single cell, and I just show you that it is not true that LFP does not catch fire. So here in the lower side of the video, it is the exact IR spectroscopy of this. So after the elapse of this 34 minutes, just see that how this explosion has occurred. The temperature was approximately of a 202 degrees centigrade for the LFP when we had recorded this thing. And after, so you can see here first that excess of emission of gases were there. And later on, once that thing came into the contact of a direct air oxygen, the fire has started. So this is the thermal visuals, how it happens inside of the battery pack is. Here is a complete of a module, the NMC, and this is the right side is the LFP. So this is the complete battery module it is, and around of a 212 degrees centigrade. So the temperature inside of this is the temperature of the battery pack is there inside of the pack, 212 degrees centigrade. Sorry, I'm wrong. This is the temperature of this thermal chamber. This is the IR camera was used. So this is the temperature of the thermal chamber. Around 212 degrees centigrade was there for the NMC, and at a 204 degrees centigrade only, because there was no enough thermal management method was used in this LFP pack. So it just propagated, and at a 204 degrees centigrade only, this LFP pack has burnt out. So up to this level, if we can, the battery pack can withstand. So if we provide the safety mechanisms for the detection of this thing, for the detection of the failure conditions, so definitely we will have the time so that we can warn our customer that the battery pack is going to fail or the fire type of a condition is coming. Through these videos, you must have been clear that it does not happen that just at once the fire starts. We have enough for time, like in this LFP, as I have shown you, as the thermal runaway has started, it was approximately of a 34 minutes of a time was there in which one can warn to his customer that the thermal runaway process is started. And if there is a mechanism to douse that thermal runaway process, the battery pack will douse that mechanism will douse the fire, which is going to happen. Or if there is a no safety mechanism in your pack, at least you can warn to your customer that the fire is coming. Just be aware, be prepared for the fire. So the standards are also based on this. So the phases, if you see, the failure stages, if you see, so it is first the abuse that you do to your pack. By any of a abuse, it is going to affect your battery pack. The second of a stage is the gas generation, that is the off gas generation stage it is. And if you are able to do the detection of this off gas stage, it is the golden time for the safety and the prevention, where we can prevent the fire. And at least if we don't have the methods for the fire prevention, at least we can warn to the people who are there. Thereafter, the off gas stage, the smoke part comes. So it means smoke part means the fire has started. And once the smoke part comes, there is almost nothing remains in your hand, so that you can douse that fire. You can control that fire. You can douse that fire by any of fire extinguisher means, but you can't prevent from your battery pack going bad. If at the off gas stage, if you have been detecting the things, most of the chances are that you will be able to save the battery pack, you will be able to save your cells, you will be able to save your vehicle or the application in which it is connected with. But once the smoke part comes, there is a very less thing remains in your hand. There is almost of a minute that remains in your hand practically. And maybe the fire dowsing systems could be there, which can extinguish the fire, but load cutoff or other things is not possible. So this is a 4-stage process. Actually, the failure is a 4-stage process for your battery pack. So if we do the off-gas event detection, that is one of the best thing that we can do with our packs. You must have been encountering, there are lots of IoT solutions are there, which keeps taking care of your temperature of your battery pack. Maybe the cell level temperature monitoring are also being done. Thereafter, the thermal management, active thermal management methods are used. So they also have the temperature measurement system. So these all are the things are being implemented. But think of a scenarios that if due to the excess of a heat, your electronics has started failing. So at that time, you don't have the enough of measures to do the load cutoff or to create, to open up a valve, which is there to release the gases. So that for those conditions, the off-gas event detections are becoming now the standard. And many of the good packs, specifically for the larger electric vehicles and the storage battery packs, this has become a norm now. Sooner or later, it will come for the two-wheelers also. So be ready for these things. So that's what the discussion is. So so whenever this off-gas event is detected, so shut off the pack at off-gas release state. That's what the thing that we need to do. So either you do the load cutoff, or you might have a valve in your battery pack, which you can open, and the gases, which is, we have to actually do what if there is an access of a gases that is being produced into our pack, that gases should get released. If there is a release of a gases are happening, there is no way that the a cell capping or the battery pack casing will explode. But if the more of a bulging of the gases are happening inside of the pack, so it will definitely going to explode the cell capping and the battery pack casing. So this thing that we need to do. Thereafter, the once you have cut off the load, but still there could be a fire could have started. So we do the monitoring of the smoke also. So it is a 2-step process that we do. Now, the problem with the gas detection mechanism is that the battery chemistries are different. There are the different of the batteries chemistries are, and it is constantly evolving. So the ratios of the productions of the gases, the different types of the gases, all these are different. So it becomes almost almost very typical for the system designer part for to do a standard monitoring process. So that's why these all are the in a form of a customized environments, and for the different of the chemistries and for the different stages, as you can see over here that like it is a discharged lithium ion, so only carbon dioxide that we are getting emitted. But if it is a fully charged lithium ion and MC chemistry, so we have the combination of hydrogen, carbon monoxide, and carbon dioxide, all of them. So the system should be capable for the multi gas detections, and for the different of the volumes, even for the lower ppm values also we need to detect. So this is what in off gas event detections are there. Just see this video that what happens if we don't have the gas detections. So this is a LFP chemistry cell, and this is the cell cappings are there. The access of a charging that could be done, and just after that, the access of a bulging of the gases would lead to the breakage of this cell capping. And just see over here that, yeah, see over here, there are some materials. So once, just see this stage. As you can see, there is a certain of a vibration into the cell has happened, and some of the materials that has extruded over here out. So it has actually broken the cell capping, and the internal oxide material has come into the direct contact of the air oxygen, and which would further lead to the catching of the fire. So this time, if when the gases were bulging inside of the cell, if that thing could be detected within the pack, so we can have some sort of a relief. There are a few hand raises are there. So can you please write your question in the, if you have a question, so please write in the chat window. If it is required to be taken right now, I will take it, otherwise at the end. If you have any query, please write in your chat window. This is the energy storage battery system, and you can see here the gases are emitting out, and further. So this is a Chinese energy storage system. So further of this, once this oxide come into the contact of a direct air oxygen, that thing leads to the fire conditions. So these are the multiple of such things that you can see. So what is the, how do we do the gas analysis? So two of user case scenarios I have taken. If you are planning to do the gas analysis in your pack, so just how this is a little of an idea that is over here. So for a like an NMC pack of a 15.2 volts and LFP pack also for 15.2 volt, and the capacity which is 75 and 82.5. So in this NMC, you can see that the total hydrocarbons, that is release rate is 113 liters of a total release is there per minute. See this enormous amount of a gas release, which comes at a flammable range. If it is the 165 liter of a per minute release is there, so that thing will come in a flammable range. If it is the carbon dioxide is there, so it is the 471.1, the carbon monoxide is 33.8, and hydrogen is approximately of a 52.4. That is the pack release rate per meter. This is the amount of a liter per meter, and sorry, per minute. If it is this is the non-flammable range. So if it is there in these ranges, which is 17 and less than 1 and less than 17.3, so it remains in a non-flammable range. So this thing is the gases that those are emitting out, and we need to measure these exertion of the gases through the help of these gas sensors, and we can develop a mechanism through which we can do the cutoff of these loads. Approximately of a 41 liters of the gases are emitted on an average from one cell during this thermal runaway process. Whereas in the case of the LFP chemistry, if you see, so the ratios are quite different. Here it is the 35.8 is the total pack release rate. So the sensors which we are using and the mechanisms which we are using, it should be having the different of the ppm range metering features, so that it can do the measurements of the different ranges of the gases, different volumes of the gases, and based on which we can do the things. Here, if it comes at a 357 per liter per minute, the ranges, so that thing will lead to the thermal runaway and the fiery conditions. So this is off gas event detection is there. That's what is a one mechanism. And the second of a things, more of the time people ask, the smoke will also come from the gases. Once the off gas event will happen, so a smoke will also come. So why don't we have just a smoke detector signal, which will be low cost, and we can also do this thing. But there is a difference. If it is an off gas event, so you have almost of 11-12 minutes of a time, that is a golden time we can say. The gases started emitting out, and you have approximately of this time, so that you can warn to the people or do the load cutoff or the opening of the valves and all these things. So the safety measures that you can take. Whereas if it is just a smoke detection signal that you are using in your pack, so the smoke is at the end once the fire is just going to start. So you don't have remaining enough time in your hand. So that's why the smoke detector signal mechanism is not good for the safety mechanisms, whereas the off gas is being implemented more and more. There are the again, there are the perspectives related to the BMS. So battery electronics, it is not only the BMS, but other of the monitoring systems are also. So there are the two types of the BMSs are again in the market. One is the very rigid BMS, just as a protection device, which is doing the maybe cutoff, or even most of the time it does not do the cutoff also. It is just keep measuring the voltage and the current what you are using in your pack. So that's a rigid BMSs. And then we have the BMSs with a state of functions, that is the state of charge, the health, the thermal management, the temperature, the balancing, all these things the BMS is doing. So whenever we are going to make a safe battery design, and whenever we are going to have a performing battery design, we should always be looking towards the BMS, which is having the state of functions at least, so that you can get the about your battery pack, you can get the behavioral knowledge about your battery pack, you can get the different of the parameters of your battery pack. It should be giving you, it should be ensuring you the safety and the security, and the different of the state of functions estimations will lead you to know that how much the energy the pack can deliver later on. Uh, what is the curve that the delivery of the energy that your pack is following? Is the pack going under health, or is the pack being utilized more, or overcharging or undercharging? All these informations that you can get through the through the data from the BMS. And this is what we should be looking towards, not just a protection device, which is doing just the cutoff of the based on the voltage and the current. There is a regulatory framework thing is also that is also concerned with. So if it is the EV ecosystem that we are talking about, so for the safety, the regulatory frameworks are there for the safety, for the performance, and for the durability, all are considered. So under the regulatory framework, it is the first of it is the Ministry of Road Transport and Highways. So that defines all of the rules and the regulations. And Ministry of Heavy Industries is there, which is for the incentive schemes, that FAME incentive schemes that you have heard of. There are the and the regulatory bodies are there, which is the CMVR. This is the Central Motor Vehicle Rule Regulations are there. And then there are the Automotive Industry Standard Committee. So AISC is looking towards the new standards and the regulations which needs to be framed. Once that regulatory is framed and it is accepted within the ecosystem of that AIC, it goes to the CMVR, and further CMVR passes it and send it to the ministry for the generalizations and for the kind of execution of those standards. And then these RI and the ICAT standard that you must have heard of comes. So that rule is given a number, a IS number is given, and then it becomes a standard. So there are the labs are there which follows those standards and do the regulatory tests for your vehicles or the battery pack. So there are the different of regulatory bodies are there, like in case of India, if it is, so it is the RI is there, ICAT standards that we follow. There are the UN regulations are there. In European zone, it is the R100, R101, these rules are there. In case of American zones, it is the SAE standards are there for the vehicles. In China, it is GB by T rules are there. ISO and IC are the global standards. So there globally, if you see, it is the GT rules are there. So there are the a variety of standardizations are there, and more of them almost they have the certain of similarities, but some of the standards have been derived as per the conditions, environmental conditions, and the performance conditions of that particular geographical locations also. So specifically the green diamond that you see, so it is there for the electric vehicles specifically. So we have this AIS 038, revision 1 and revision 2, AIS 048. And there is a new regulation is there, AIS 156 is there, vehicles, which takes them as a complete of a system. So these are the standards that has been followed. So there are the multiple of standards for the electric vehicles, for the HEVs, for the retrofitted vehicles, like there is an IC engine vehicle and you are retrofitting it. So there are the multiple of standards are there, but specifically for the battery, these standards that we follow. So all of these standards are looking towards the mechanical, electrical, environmental, and chemical, these 4 types of abuses and the tests related to it, which is there again in the safety and the performance of the battery pack. Globally, these are the different of standarding bodies are there. And in context of India, it is the AIS 048 and AIS 038. That is the 2 more important related to the battery pack is there. UL is there for the safety standards. US ABC is there for the specifically for the United States battery. Our standards are there for the European zone, and then GVYT is for the Chinese. So AIS 038 and revision 1 and revision 2. There are the 2 revisions are there. So just stay for a few more minutes to know about what are the standards followed and how the tests are performed for the safety conditions, specifically for the thermal runaway, how the tests are performed. So that's what I'm going to let you know. So it is the AIS 038 revision 1 is there for the LMNN, that is your 2-wheeler and 4-wheeler and the higher category of the vehicles, which is aligned to the European R100 standards. Whereas the AIS 048 is there for your traction battery packs specifically. And there is a system level approach is not yet into the AIS 048. It is the cell level approach that is still followed, like a short circuiting, vibration, shock analysis, penetration tests. So at a cell level, these tests are performed, not taking the whole into a system, not into a complete a battery pack level tests. These are performed. Thereafter, the tests those are conducted are under the electrical abuses. So they conduct the short circuiting and overcharging tested, whereas under the mechanical, they conduct the various of penetrations and the vibration and the mechanical shock tests. So these are the setup benches, few of the figures that you can see, which is used into their testing environment. Whereas in case of AIS 038, that is specifically for the new type of electric vehicles and the traction battery pack rechargeable energy storage systems. So it is aligned to the GTR 20 rules, global technical regulations, which is India is also a part of it. And the system level approach is followed in this AIS 038, which is there for the vehicle and the battery pack together they are taking. And in this, they are doing the thermal propagation and thermal also. The BMS which you are using for this, it should be ASIL D compliant. It is the automotive safety standards are there. So whatever the chipset is there in your BMS, it should be ASIL D compliant. That's what the requirement is. So, and there is a one more standard is there that, so this AIS 03, it is there for the 3-wheelers and the 4-wheeler categories, but specifically for the 2-wheelers, AIS 158, 156 is the standard that is followed by the new manufacturers like the Ether, Ola, all these are taking the tests. So the tests that on these vehicles, that's this AIS 156 have been performed. That is specifically for the 2-wheelers. And this is again being formed based on the R136. So it is taking the battery pack and the vehicle together. So a system level has been followed in this. It has the 2 parts, the vehicle safety and the battery pack safety to get separately tested, and they are tested again together. So that's what a system level approach is. So many of our manufacturers who were earlier doing the ICAT testing of the battery pack only are now going together with the vehicle and the battery pack for this test under the AIS 156. And the new chemistries, this advanced chemistries are there. So those are also being tested under this AIS 156 only. The L categories, so there are the that is performed under this is the mechanical and the electrical tests for mainly. The thermal test is there for the specifically the thermal propagation test. So how this thermal propagation test is there, that is more related to your safety of your pack. So the ignition of a one cell is done within the battery pack, and then this how this battery pack ignition is leading to the propagation of a heat to the others of the cell present in the battery pack, because based on which the final the cell by battery pack will come under the heat. So that's what the test that has been performed. So ignition of a one cell is being done either by heating or overcharging or by just penetration, and then that emits a large amount of a heat and a flame, that cell, and that heat is being propagated to the other of the cells. So there is a time period. So this is the once that a cell ignition event is happening, from that time period, there is a time that has been derived, that the thermal warning event. So if the temperature is rising, so that thermal warning event should come. And from that time, 5 minutes is the time that you have been given to warn to your passenger that within 5 minutes, the fire is either started or the fire is going to start, and it will reach into the passenger compartment. So you are having a 5-minute period in which doing the detection and warning to your passenger, so that the fire should not come into the person who is there into the passenger compartment should not come into the under the attack of the fire. So this is a test that is being performed, and for this, this is the test at the physical level. And for the warning systems, it should be integrated either into your battery monitoring system or into your BMS system. So whenever this thermal event is happening, that should be this time, the thermal event warning time, and this warning, the 5 minutes period that you are getting, it should be communicated to your vehicle communication unit by any of a means of a communication, if it is a CAN or any of a proprietary protocol you are using. So through that protocol, the BMS or your battery monitoring system should communicate to your vehicle communication system, and it should be depicted into the dashboard instrument cluster that the fire is going to happen. There are the three of a detection parameters have been drawn. That is the first, it is the cell voltage will start dropping due to the fiery conditions. The temperature might be rising beyond of a limit which the OEM has fixed, or the rate of increase of a temperature is beyond of a 1 degree centigrade. Normally, the rate of increase of the temperature in the cell is very low, less than 1 degree and even half degree centigrade. But if the thermal runaway condition is going to happen, that rate of increase goes beyond of a 1 degree centigrade. So if any two of this thing is detected, so this warning message should come on our VCU unit. So that's what is the another safety mechanism that combined from the battery pack to the dashboard system that is required, and it is a standard now under the AIS 038 revision 2. And similar is implemented, been revised into the AIS 156 also. Right now, this thermal propagation test is not there in the AIS 156 for the two-wheelers, but the fire safety norms are being prepared, and this thing will implemented into the also. The new offer standards that is being worked on are on the UN GTR related to the durability, the minimum assurance of the performance of your pack. So you will have to implement the system in your battery pack where you need to tell in a certified way that how much the energy that pack is going to deliver now. Like you have used your battery pack 5 years or 6 years or 3 years, any of a time period you have used. So the customer should be able to know that how long my battery pack is going to last and how much amount of energy that I can get. So that's what kind of a durability assurance kind of a test, the durability assurance kind of a certification that you need to provide on your pack, and the standards are under process for this. it is under UNGTR. So each of a country has to implement this standard. The fire safety standard is under progress as related to the thermal propagation test, and a few of the standards are coming up on the uses of the fire extinguishers also. Thereafter, the EPA range labeling rules. So this is specifically for the, as per the US governments, where we need to label that how much range the battery pack is going to give. So like a substandard, there are lots of substandard products are there into the market, and one is not sure that what the battery pack I have purchased, how much range it is going to give me. So that range labeling you will have to engrave on your battery pack, and as per that the battery pack should be there. And the star rating of the battery pack is also under progress. So these are the new standards that will come within year. Mostly most of the things related to the UNGTR and fire safety will come this year. Related to the EP and BE will be maybe 2 years it will take. So these are the standards related thing. Now, one more thing related to the security. So as I have talked about that the communication is required in your pack. And nowadays, so the battery is communicated, it should be giving all the kind of a data to your monitoring systems and the dashboards. But what happens that if that battery pack is not authenticated, or the battery pack is not from the valid manufacturing source, or maybe your cloud, through your cloud, the battery pack is hacked. So there are the multiple kind of things that might happen. The second of thing is that you must have seen that the chargers. So like if it is a Ola battery, so that will get charged through the Ola chargers only, or it is the hyperchargers through only, or maybe the Ether is supporting their battery pack. You might have a requirement also tomorrow that if my vehicle is there, so my vehicle should have only mine battery pack. That's the proprietary battery pack. It should not have any other battery pack, because if tomorrow there is a substandard battery pack is there in my vehicle and that battery pack catches fire, so that can burn my vehicle also. So how to prevent such kind of a counterfeits and the profits and specifically when this swapping ecosystem is going to implement. So there is a authentication mechanisms that we need to implement. So that authentication will be either into the BMS or a separate of a module as authentication module in your pack. So if it is a IoT BMS, so it is better to implement the authentication in your BMS itself, where it gives you the secure boot features and the certifications, the security certifications, and whatever the messages that is coming through the cloud, it should be encrypted and the certified. Or if it is the separate of a module that you are implementing, then that separate module can also have the similar kind of things. So for this, there are the hardware level and the software layer, both layer of a security that is implemented. Like hardware layer, if I'm talking about, so from microchip, it is ATECC608A is one chip which is implemented. But for the retrofitment purpose, lots of time it happens that we don't have the enough place, or maybe we don't have the enough of a scope to implement one more chip into my BMS, or to integrate one more chip into my BMS for the safety and security purpose. So there is a one complete connector type of a thing is being brought out. This is a TA100 connector is there, which has the inbuilt security hardware and the certificates that can be signed on those hardwares, and those things can be later connected with your cloud. So TA100, that's the integrate that could be integrated with your battery management system, and on each of the battery module, this TA100 will be implemented, and further it can be communicating with the battery management system. So we can have a trust and authentication feature in my battery pack, where from the charging end to the discharging end, we can create a trusted environment, and to the cloud, and also we can create this trusted environment. So the battery pack won't get the counterfeits, the EV won't have any of an unauthorized battery pack, or your battery pack could not be used with any other powertrain which is not authorized by you. Similar way is there for the charging systems also. So this is the thing that we can implement. So it is a complete chain system is there. So if you are into the IoT domain, you can understand this, that there is a certificate signing is required. It is a public and private key architecture that we need to follow over here. One is your private key, another is that is from the manufacturer, and then we have the public key from the cloud side. And both of the things needs to be signed, and then it has to go into your chipset, that ATECC608A. Further the certificate, so for further of the signing of the vendor and the manufacturer of these semiconductors together leads to this root creation of this root of a trust, and it has this X.509 certification. That's what is also, that's a certificate signing thing is required. So it creates a complete root of a trust into this chipset, and then whatever the communication that is happening through this chipset, BMS or the cloud, and between the two of the battery packs, or between the BMS and the powertrain, or between the BMS and the charger, it comes under the it comes under the trusted communication environment. So this is one of the requirement that you need to think about implementing in your BMS sooner or later, so that it would remain secure and safe. The last of the thing is that related to the manufacturing. So everything, the design and everything that we have done, but if you're following the manufacturing practices, so if the proper of tools and mechanisms is not been followed, or it is a more of a manual process we keep, so that thing is again going to create an issue. So there are the two ways. One is just an automation, where you have the where you have the machines just to improve the efficiency. The man are using those machines, and the things are happening. That's just an automation. But you can create a very limited level of security into the manufacturing practices with the help of this automation. So this Industry 4.0 implemented manufacturing practices that is coming now, which is interoperable manufacturing practices, and you can control the rate of your manufacturing, the alignment of the manufacturing, and the introduction of these cobots lead to the human working with the machines together and increasing the efficiency of this. So few of use cases like the bus bar, which is getting tightened on your battery pack, like the PCB, which is going to tighten on your the BMS PCB, which is going to tighten on your battery pack, like the tool positioning system. So these are the kind of use cases are there, which is there in the systems, which should be there, and can give the level of security into the complete of a manufacturing practice. Like a tool positioning system. So either you do a manual positioning of the nuts and bolts and everything, or you can have an X and YZ coordinates gathered through the machine vision, and based on which you do the tightening of your bus bars and everything. Similar of a way, there are the racks are there on which the raw materials are there. So the machine vision can see that which one raw material is in a good condition, which one is in a bad condition, and at the time of the taking of that raw material itself, you can sort that whether it is in a good condition or not. So then the battery bulging test. So maybe some of the the cells were good sorted, but during the welding process, or maybe during the packaging process, some of the bulging in the cells has happened, and that will lead to the problem into the battery pack later on. So once the battery is packed, so we can have the bulging test through the machine vision. There is a single machine which can do the internal resistance, OCV, and impedance test of the complete cell and the battery pack once it is got manufactured. So these are the different kind of machineries that is there in the testing environment, specifically for the safety assurance into the manufacturing safety aspect. So even if everything is good, but by implementation of such things, we can assure that whatever we are delivering, that is safe, that is cross-checked, and that is working properly. So as a part of the precautions, if you ask me, so it is the thermal management method is the most required thing in your battery pack. What the three things I have talked about, it is the thermal, the mechanical, and the electrical. These three things must have been in your design pattern itself, so that you can be assured that any of untoward situations should not happen to your pack due to the known regions. The C rate management. So whatever the C rate that battery pack is supporting for the charging and discharging, you should have the powertrains as per that. The gradings of the cell you should be doing. The internal resistance you need to sort around, and only the similar values of the internal resistance should be there in one pack. So cell grading and cell sorting machine we should have. The capacity sorting machine we should have definitely. The process in our process. The heat management of the electronics also we need to take care of, because we have the electronics in the BMS, and that will also dissipate heat. So that's what also we need to take care of. Further of it, it is the IoT enabled systems if you are implementing in your pack. So you can have for the measurements and the monitoring. The gas monitoring system is one advantageous thing that is going to implement it now. The fire extinguishers are also few of the companies are implementing. The complete of a design to manufacturing process that you need to develop, and as per that you need to work on. The separators, thereafter the gap between of the cells, the thermal propagation test, the other things that we need to take care of. And whenever the battery pack casings are designed, so it should be there as per the chemistry and the capacity and the temperature in which the pack is going. You should have the enough heat insulation methods into that. It is not just that what the market, what is available in the market, let's just pack my battery into this. So it should be, everything should be customized. That's what the things we should take care of, and we can do a level of safety in my pack. 100% is never possible, because the things are evolving, and as it is a physical thing, it is not an absolute, as there is a physical matters are involved. So something new can happen in the chemistry at any of a time, but still, even if any of the untoward thing is happening, your system should be enough intelligent, your system should be enough capable, so that the conditions which will occur due to the thermal runaway should be dodged off, should be taken care of. That's what is the requirement for the implementation of the safety in the pack will remain always. So I think this is the end of this session is. Before I take your questions, let me just paste the feedback link. So this is the feedback link is there. I will request each one who are connected to give your feedbacks to this. And now, if you have a question, so definitely I would love to take the questions now. So you can unmute yourself and ask your questions. There is a hand raising of Mr. Pavan Sehra. Mr. Pavan, you have any question? You can ask me. You can unmute yourself and ask me question if you have, or any of a participant who is connected, if is having a question, he can ask me now.
Hello.
Yeah. Yeah, Mr. Has.
Good evening, sir.
Good evening.
I have one question that we are going to use that lithium-ion cells, right? That
Yes.
steel body. Why we are not using like a polymer made like mobile, just like built-in mobile? Means that are conflict. Yes, sir.
The polymer cells, or it is the pouch cells that you are asking about?
Like pouch cells.
Pouch cells are being used in the four-wheelers.
Yeah. So sometime I have learned sometime I used to see sometime of Tesla videos, and they show their Tesla battery like lithium 18650.
See,
the size one.
Yeah, 18650 is the cylindrical cells canning size. So 18650 is available in the NCA chemistry, right? So NCA chemistry cells, mostly the Tesla is using is in the cylindrical format, but NMC chemistries and NCA chemistry, they are also using in the pouch cell format. Tesla is also now using the LFP chemistry in the prismatic one. So it is not limited that one company is using only one cell. Like the Bolt EV, which I have taken an example. So Bolt is using the LG Chem pouch cells. So it is there. There is a little issue.
Okay.
Two-wheeler is there that whenever the charging of the pouch cell happens, so there is a certain of a limit of a swelling is there in the pack. So you need to leave certain of a space in the casing so that if the cell swelling happens, so it should be adjusted. But in the two-wheeler packs, we don't have enough of a space. So, and implementation of the thermal management method is also little typical in the two-wheeler packs because of a space and the a cost factor. So it is avoided the pouch cells, but four-wheelers, we have the space and the cost flexibility also. So companies are using it.
Okay, sir.
Thank you.
Sir, I have one question more.
Yeah, please.
So why don't we use some kind of a breather kind of thing? Just like I used to belong from the electrical branch.
Great.
Electrical engineering branch.
Yeah,
I have once visit through the substation. There we have one battery pack. They are using around neodymium cadmium battery. Okay. They use some kind of a breather to avoid that swelling. Why don't we are using kind of
trigger for what? Trigger in the form of what? And the swelling of the cell?
Not trigger, not breather to that gases out from the battery.
Yeah, so that is possible. That's what the valve I'm talking about. So we can have that valve. People are implementing it into their battery packs, the valve kind of a mechanism, so that if access of a bulb gases are there, so it could be emitted.
Oh, thank you.
So one is the mechanical methods, but through the mechanical means everything could not be assured. So that's why sensors methods are there, so that you can, because in the mechanical method you require a limited a necessary amount of a pressure, and the variations will be there. Here in case of a lithium-ion, the variations are there. In a charged stage, discharge stage is both. So only the mechanical methods are not working. So that's why the sensor methods are implemented. So that the proper of a sensing in the different of the conditions of the battery pack would be done, and then the valve could be open or the load could be cut off, so that the further of thermal propagation won't happen. So that's how it is implemented.
Okay. Thank you, sir. Thank you.
Hello, sir. Good evening. My name is Tejinder Singh.
Yeah, good evening, Mr. Tejinder.
Firstly, I would like to appreciate the very well formulated presentation, and it was really very interesting for a candidate like me, because I'm very new to battery segment. Good to know. And thank you so much for a lovely presentation. It was quite clear, and the diagrammatic and visual aspect was very good to understand certain things.
Yes, great.
I have one question. If you can, throw some light on the type of cells, because like there are different numbers, 18650 and so many numbers.
Okay, great. Yeah.
And how we classify them, and which brand is better. I heard about BAK, High Star, so many companies.
Yeah.
So which brand should one prefer?
Okay, so let me tell you. The thing that you have asked me about is about the form factors, the 18650, 21700, 21650, 32650. Now it is the 42650 is also coming up. So these are the form factors into the cylindrical form, right? So like if it is a 18650, it means 18 mm is the dia of this cell, 65 mm is the height of this cell. 0 represents that it is a cylindrical. So any of a number, any of a time now it comes in front of you, you should understand that it is a cylindrical cell and it has the dia and the height, the depiction, and 0 is for your cylindrical way. That's one thing is clear, the different of a canning mechanism.
Yes, sir.
Yeah, it is there in the LFP chemistry. We have generally, what is the general availability is, in the LFP chemistry, we have generally available 6 AH capacity cells into 32650 dia package, and the NMC is generally available in 18650 package of 2.5 AH or up to 3.2 AH of capacities. This is general availability. NMC cells in a cylindrical format, you won't find beyond of a 3.5 AH of capacities in a 18650. The prismatic cells are also coming up. So prismatic cells are in a rectangular form, and mostly the LFP chemistry is there in the prismatic cells. There is a problem with the LFP cells that they have the higher self-discharging rate. In the cylindrical form, it becomes little incompetent. They become incompetent in the EV domain. So that's where the innovation has been done, and the prismatic form factor has been derived for them. And nowadays, around of 86 AH, 90 AH, even 150 AH, 175 AH of a prismatic cells that you might see in the LFP chemistry. Then we have the pouch cells. So pouch cells are also used for the LFP chemistry and for the NMC chemistry both. The pouch cells in the NMC chemistry and the cylindrical one and the prismatic cell canning, both are having the cans of a metal, whereas lots of time we require the weight of the cells should be lesser. So to solve this problem, we have the pouch cells. So pouch cells have the polyvinyl casing, and the NMC chemistry and the LFP chemistry is there inside of it. There is no form factor change. There is no deformation happens in case of a cylindrical and prismatic if it is charging and discharging. But if it is a pouch cell, so once you are charging, little of a swelling will happen. If you are discharging, so cell will settle down. So that's what the three form factors are there. In the one, we have the fixed sizes of like 18650, 32650. These are the fixed sizes of the cans are there. But in case of a prismatic and pouch cell, there is no such kind of a restriction. It is as per the application, it is as per the manufacturer that who will be making what sizes of the cell as per his application. Like the lithium-ion cell in your laptop, it is also a prismatic cell. The lithium-ion cell which is getting used inside of your maybe Bluetooth earphone, that is a pouch cell. So such kind of things are there. The another thing that you have asked me about the brands. So there are the multiple of brands are there, like the back is there in the lower category. Thereafter the good brands. If you are asking me about the NMC, so it is the LG one, LG Chem, Samsung, Panasonic. These three are the better one for the Indian environment conditions. Most of the companies are using the LG Chem and the Panasonic cells in their battery packs. Samsung cells are little lesser used over here. Whereas in the budget, pocket friendly cost, if you are asking me, so BAC is one of the company who is supplying their cells. In the LFP chemistry, people are high quality cells are the Cattle and BYD cells. Whereas in the budget friendly, it is the FB Tech cells people are using over in India. Thereafter A123 systems cells people are using into the India. U Better cells people are using into the India. So these are the different of the brands. But this is it is irrespective of any of order. These are the different of the brand names that is there. It is as per the application, as per the durability of your application, you need to select them.
Thank you, sir. Thank you so much. I have just one more query. If we have to design a battery for a three-wheeler,
yes,
L5 high-speed vehicle,
okay,
So what all important things we should keep in mind, though you showed the last slide wherein you have mentioned so many things, but particularly with respect to three-wheeler, is there any other special precaution?
So there are the certain of things that we will have to keep for any kind of a vehicle battery pack design, whether it is a two-wheeler, three-wheeler, four-wheeler, or even for the electric buses. There are the considerations related to it starts from the cell selection itself, right? The cell spectroscopy that we call. And then it is the sorting of the cells up to the packing of your battery pack. There are the design aspects related to the your mechanical design aspects, the electrical design aspects. These are all the calculations that we need to do. Thereafter, respective to your high speed vehicle, as you are asking me, so definitely you will need to give the fast charging solutions also. So you need to specifically focus on the thermal design aspects and the active cooling mechanisms of your battery pack. That is a special one. And the BMS aspect that you also need to take care of. That is special for your three-wheeler high-speed one, and as per the standards. But the basics of the battery pack is that all about these three things that you need to take care of. So that is it.
Thank you, sir. Thank you so much.
Actually, it is a complete, I think maybe participants have joined it. So we have a complete for such things. So we have a complete 6-week program for the people who are looking into the battery design and the battery manufacturing. So maybe you have heard of. So this is a 6-week program, which is a battery lithium-ion battery pack design, modeling, and safety. And under this, we let you know about all of the things of your battery design from the cell selection level up to the battery pack design and the BMS and the thermal management all. So maybe you can ask about our program. The batches keep going on. So you can join if you're interested, you can join at any of a time, and you can know that how all these things, how all these calculations, the simulations, and everything is done. So
these are online programs, sir?
Yeah, these all are the online programs. It is delivered through the faculty. I also take the sessions. So we give you the complete of hands-on experience also through the online modes. You can go to our website. Let me open the website for you, just share you. The program detail is there. Many of the people have joined from all over the world and have got benefited. I'm just sharing the course page link. In the meantime, if anyone is having a question, you can ask me. I've already shared you the feedback link, so I would request you to give your feedback also, so that it would be a moral booster for me. And next time, based on your feedback, something better we can provide you. We keep doing such kind of webinars, master classes and all. So here is a course link is there. So I've posted it just in my chat window. You can also open it at your end. So this is a 6. Yeah, this is.
Okay. Got it, sir. Thank you, sir. Thank you so much.
Welcome. So this is the 6-week live program is there. The sessions are now the batch which will open from 19th of April. It will be in the evening at 8 p.m. The sessions are of a durations of 90 to 120 minutes each. The sessions are from Monday to Thursday in each of the week. And the best part is that after your even after the program gets over, you can avail a 1-year support from us. So you are, after the training, you do the battery pack and you face any kind of a technical difficulty. So you can always come back to us and get the technical support. So for 1 year, the technical support is free for you. So this is the contents. We start with the lithium-ion cells. We give you the knowledge on the manufacturing, how it is the packaging. That's what the question you have asked me. So the complete of a relevance, that's what is there in this course. What is the charging and discharging profiles are there? What is the considerations for the storage and the cycle lives and all? Then the sorting mechanisms that we need to do. So once you are going to make the battery pack, so the sorting that you need to do. So what are the processes and how do you do the sortings? Then in the design part, we take care of your electrical design, the mechanical design, the thermal design, and all of the things. What are the different of welding methods, how the welding is processed, what is a good welding, what is a bad welding. So all these things are shown you properly. And how do you test these things? That's what also we let you know. What are the different of a safety standards and certifications that you require for your battery pack? And that is a global. This is not only for the India, but a global. Then it is the recycling. If you want to do of your battery pack, you want to come into the recycling business. So what are the things that is required for you? What is the requirement and how is the implementation of the smart lithium-ion battery is? That's what we let you know. So that's the machine learning and IoT things in the battery pack. Then if you are going to set up your battery plant, so what would be the tools and technology, the machineries, what would be the requirement, from where you can get it, what would be the cost that will come, how you can calculate the effective cost of your battery pack. If you are making available your battery pack from the bank loan, like your customer is purchasing the battery pack from the loan of the bank, so how the auditing and the depreciations are calculated. So all the commercial aspect of your battery pack. If you are interested into the taking the funds from the government, so what are the MSME opportunities are there? So we let you know about all of them. Under the BMS, we let you know about the BMS architectures. How do we calculate the different of a state of functions of the from the BMS? What is the architecture of the BMS? Or the connections are made? And whenever we are selecting any of a BMS, to select that BMS, and then the thermal management. So how do we implement the, how do we calculate and how do we implement the thermal management in my battery pack? So these all things are covered under this. There is one more thing. So I'm also sharing one more link. And this is for if you want to later on access the recordings of these sessions and our previously season 1 sessions also, if you want to access. So here it is there in our LMS. So I'm sharing you the link of our LMS, which you can, sorry. So through this link, you can join our LMS, and later on, if you wish, you can access these recordings also.
Thank you, sir. Thank you.
Okay, any more questions? I've already taken a lot of time of yours. Hope I have not bored any one of you.
Myself, Tapos Mujumdar.
Yeah.
I want, what type of batteries are used for electrical buses? Even I know those type of bus AC is there. And what type of BMS is there?
It is a traction battery pack there. So it is not a single battery pack. It is actually the from the four-wheeler category onwards, like your electrical car or electrical buses, energy storage systems. There are the multiple of the battery modules we have, and all those battery modules are connected together to achieve a particular of a voltage and a capacity. And decentralized architecture of the BMS has been followed over here. Either it is a distributed decentralized or it is the master slave architecture of the BMS that we use over here. Now the chemistry, if you will ask me, so right now it is the LFP for the public transport purposes. Mostly it is the LFP chemistry people are using. LFP under the pouch cells, mostly the companies are preferring, or in the BYD company electric buses, they are using the LFP prismatic also, and the blade battery they have devised right now, so they are using it.
What may be the motor voltage? Traction motor.
If I remember, it is for the electric buses, it is approximately of a 1200 to 1500 volts range. It is
1200 to 1500 DC or AC?
It is a DC voltage.
DC voltage.
Yes.
Oh, all are achieved by series, huh?
The battery pack series, yes.
Battery pack series connection.
Yes.
Oh. Okay. Thank you.
Welcome. Cars are generally on the 375, 400 it is told, but it is on a 375 volts. The buses, buses starts from 800 volt. The generic transport buses come on a 1200 to 1500 volts range.
That is for metro rail. It is also, I heard that is 1200 volt. I think that's also different. Metro rail is also different. That is AC, I think.
That is AC. That is AC 3-phase, I think it is.
Right, 3-phase.
Yes.
It is the DC.
Yeah, it is the DC is there. Supply is
right.
But later on, even in the cars, the inverter systems are there. Finally, the AC voltage.
Okay. Yes. Thank you.
Up to 2-wheelers and 3-wheelers, directly DC is supplied, but beyond of even in 3-wheelers also, the inverters are used for the high speed and AC voltage is provided. But beyond of that, finally, the AC voltage has been provided to the motors.
Okay. So right. Thank you.
Any further off, or shall we close the session if you don't have the questions? Our contact numbers you must have got the email, so there the contact numbers are there. It is a WhatsApp number of the help desk. So if you have any type of a question, or maybe you want to contact us for any of a program, we are there for the technology support. We are there for the training support and all. So you can contact us. I'll be closing the session as of now. Very good night to everyone. Hope you have enjoyed the session. We'll get in touch once next time the session will be conducted. Thank you.
Go. Good night.
Good night.